Okay, so hello everybody. So I'm sitting here in my office in Mikkeli at the moment, and I'm teaching environmental technology here at, used to be Mikkeli University of Applied Sciences, but now it's Southeastern University of Applied Sciences. I was glad to hear Mika's presentation there, that it does really have a quite different perspective than the one that I have prepared for you. So we will see what you think of it. Short advertisement. I was just yesterday in St. Petersburg advertising our English environmental engineering program to Russian students. So if there are any of the listeners that are interested in studying this area, that is of course free for European participants, and the next application round is in January 2018. So I have two screens here, and the bigger one is not the one that I'm looking at right now, so I will switch off my camera to be able to continue the presentation properly. And here we go. So the title is Possibilities to Enhance the Management of Wastewaters. And my own background is from research, but I have made this kind of as a story and try to include various aspects that I think that are important at the moment globally. So there are several drivers that make taking care of our water resources in the world very important. One of them is, of course, that we need to protect nature, and we need to make any processes such that they produce a very small amount of carbon dioxide, if at all, to fight the climate change. And water is of course valuable because we need it for drinking every day, and there's a shortage of clean fresh water for this purpose. And agriculture also needs quite considerable amount of water. So any ways of saving water or purifying water to be used for these purposes is valuable. Then there's this security aspect that we have, I think, weekly news flashes on some floods and so on around the world. So this increased dynamics in water systems or in the weather, they will affect water handling in urban areas as well. So it is important that we try to make our sewer systems, for example, as well equipped against these dynamics as possible. So then the trends in actual water systems requirements that the rising energy price that I didn't mention on the previous slide cause is that we have gotten and will have in the future more and more biogas units to produce energy out of the sludge produced in these processes. Then we try to, using the energy out of the sludge is one way of making wastewater treatment more carbon neutral. So it leads into that direction. But generally, energy optimization of processes is important, and that was seen in Lahti Aqua as well, as one area where development is being done. Also tied up with that is this smart data usage. So you can try to cause the data that you collect through more and more sensors, try to process that into information that can be used in adjusting the process, so that, for example, the energy usage is then minimized, or the quality of the sludge is such that it can be optimally used. Then, as this last step, I put here clean for use and recycling. So that means that you do not every time produce water that is 100% clean, but for these agricultural uses, for example, you can then produce water that is suitable for that use. Then, of course, you must take into account regulations regarding what type of produce you can produce in land that has this type of irrigation. So as I have understood that biogas has been handled already in a previous presentation in this project, I'm just touching that very briefly. So listed here are like things that are used in developing biogas processes. So you can have thermophilic or mesophilic reactions, or both in the same process. So you can have, and then you can have several stages, one for hydrolyzation stage and one for the actual methanogenesis. You can have improved automation and control. You can add possible extra organic material into the process. Here I can refer you to an article by Mr. Luste, where he was a co-author. So if you search Bioresource Technology, Volume 100, Issue 1, you will find there an article on increasing biogas production through co-digestion. Then, for example, here in Mikkeli, as we are building a new wastewater treatment plant, we will have a separate organization that will handle the sludge and producing the biogas. So I think this is a trend also, so that it's not 100% handled by the wastewater treatment plant company. Here we just have a list of some process options that you can have for biogas production, and a picture of the process steps that take place. Then a good thing to note, and something that I was actually waiting for already before 2008, is that you can have a biogas unit in the process model as well. So that's a good development. Then this trend about carbon neutral wastewater treatment. There already before it was known that you can produce so-called LAF gas, nitrous oxide, if you have suboptimal conditions. That is still the case, but now some sensors exist for that. So it's possible to take this information and, for example, lower the amount of aeration up to a point where you see the increase in the nitrous oxide production in the denitrification, and find an optimal point in there. The energy optimization can be also aided by using the models, because they have nowadays this energy usage information on specific sub-processes. So it's possible to include this information in any optimization that you do using the models. Then one property is that you can set limits for effluents, also parameters inside the process, and make this type of graphical representations of those, and you can have this type of model version at the actual wastewater treatment plant being used. And then normally this is supported by some consultant that has been doing the actual model. And here's just an example of this type of system. There you have here, this is 100%, because the actual total Kjeldahl nitrogen, which is around 50 milligrams per liter in the influent, was calculated so that the limit is about 12 milligrams per liter, which is 70% of the 70% reduction. So here this is from our old wastewater treatment plant, so that there we don't reach this 70% reduction, but in the new one that is a requirement, so that will be reached. Then this is like just an example of model building process, and I think this is important in the way that we are nowadays trying to build quality systems into building these models that has been done by IWA task group on good modeling practice. Separate piece of information there. So then I think I will just move over this integrated urban water systems management approach. You can read it here from the slides. So this just means that you have like not just the wastewater treatment plant, but you have a catchment area included, and then the rivers included. So you are talking about modeling a larger system at the same time. And this is something you can nowadays do. Previously, it was not this social and political aspect if you go to developing countries. So that is also something that in certain projects is important, but not, of course, if you are just trying to make the water treatment system as good as possible. LCA is one trend that has come up lately. So this is what I commented to Mika's presentation, that you can also not just calculate the cost over life cycle, but then take into account the effects on effluent quality and the nature also. So there is some methodology there. So then to the actual control methods, they are quite few actually, if you think about how dynamic a wastewater treatment plant is. The main things are air feed and the internal recycle, and this sludge wastage percentage. And the aim is normally to use minimum aeration to reach nitrogen reduction targets. And the energy usage of the pumps increases more than the actual amount of dissolved oxygen or transfer of oxygen to the sludge. So therefore also it's important not to use too much aeration. Ammonium measurement is something that you can use for adjusting the aeration. So here's some basic data on the adjustment principles in a regular activated sludge. So the amount of circulation has an effect on the amount of nitrate in denitrification. So you should be able to transfer enough nitrate to denitrification. But then if the circulation is too much, then you can bring oxygen there, which is not positive. And then it's mentioned that nitrate should be available in the whole anoxic area through efficient circulation. Then there's this addition of external carbon source. So if you have a municipal waste that has like high nitrogen concentration or very low COD level, then this might be beneficial. But of course it will increase then these three things that are mentioned here. More sludge will be produced, more aeration energy will be used. And to adjust the additional carbon source addition, you can do that by having a nitrate sensor at the influent and then at the end of the aerobic sector. Then this SRT time is something that is like not so easy to know what is the best solution, but normally you try to keep it as short as possible without sacrificing the nitrification at high loads. And there's given some idea about the length that could be. And then this is normally not automated, but you just adjust it manually by this changing growth rate of the nitrification bacteria, which then is higher when you have higher seasonal temperatures. So as we have gone a few minutes over the time, so I will skip this slide and move to the so-called smart adjustment. Well, the question is there any smart adjustment? I think that actually, if you think that smart adjustment means like the thing mentioned in the last bullet point, using these neural networks or some nonlinear models, I think at the moment that does not exist. It's still something that maybe in the future, or then again not. Normal smart adjustment would be having enough of these modern sensors to know what's the level of ammonium, what's the level of nitrate in different positions in the process, and then doing the optimization based on that, as is here described. You can use these neural networks for then self-organizing maps, for example, for like picturing the situation in the process, and it's also possible to include the data from a model that is using this type of loops also directly into wastewater treatment plant automation, but in my knowledge that is not being done at the moment. So I think that was time permitting what I had. Thank you, everyone.
Thank you very much, Hannu, for this comprehensive presentation. We are looking forward to some questions that you can ask in the chat. Okay, Sami has a question. So he's asking, to summarize this, what would be the first step for the wastewater treatment plant that would like to enhance the maintenance of their process entity? What can you possibly advise, and how is it possible to prepare for this?
Well, my understanding is that the prices for just general sensors have fallen quite dramatically. When I was doing my PhD, the prices were around 15,000 euros for some online ammonium or nitrate sensors. So I think that must have fallen considerably. So I think that just get the sensors. That way, for example, mentioned here in the presentation, and then use those for adjusting the process. I don't recall the actual adjustment processes now, but that can be found in the literature quite easily. Somebody's asking where can we find the full version of the presentation. Is that? I think it should be available.
Yeah, so if you give consent to share this for us, then it will definitely be available through our official project website, www.ivama.eu, after the webinar, and as well as the recordings of the webinar with the speech and the video.
Yes, that is fine, of course. And then at the last slide that you hopefully see now, you have my contact information. So if you have any questions, please just let them come through.
Yeah, so you can contact Hannu to discuss what interests you further. Please think of any more questions, but if you need some time, as far as I know, also Hannu has prepared some questions he would like you to answer and to vote for, so they would appear on the screen if no more questions from participants are coming, and then you can answer them as previously. So, do we have any more questions? No, so perhaps we can run the questions from Hannu.